This video is solving systems by using substitution method. So looking at our first example, we have two linear equations. We have x plus 8y equals negative 15. 7x plus 8y equals a negative 9. What we need to look for here is we need to figure out which variable is easiest to solve for. We're looking for a variable that does not have a coefficient. So looking at my two equations, this x variable does not have a coefficient, a number in front of it. So I want to solve for x. In order to solve for x, I need to end up subtracting 8 from both sides, so 8y. That gives me x equals a negative 8y minus 15. Now that I have one variable solved for, I'm going to substitute it in. What that will look like is I'm going to take this negative 8y minus 15. I'm going to plug it in for this x value because it says x equals. So I have 7. I have 7, but instead of x, I'm plugging in negative 8y minus 15. I have my plus 8y equals a negative 9. Okay, from here, all I'm going to do is solve. Notice, this equation only has the y variables. Okay, we replaced the x, we substituted a value in for x, so we no longer have x. Okay, so I'm going to end up distributing. 7 times a negative 8y is a negative 56y. 7 times a negative 15 is a negative 105. I have this plus 8y equals a negative 9. Now I need to combine my like terms. So here are my two like terms that I have. Negative 56y and a positive 8y. When I combine those, I get a negative 48y minus 105 equals negative 9. My goal is to solve for y. So to do that, I need to move over this 105 by doing the inverse operation, which would be adding. This is where we have to be careful. Negative 9 plus 105 is a positive 96. I have a negative 48y. To solve for y, I need to do the opposite, the inverse operation, and divide by a negative 48. Y equals 96 divided by a negative 48 is a negative 2. Now that I have solved for this variable, I can use it and plug it back into this equation right here to solve for x. Okay, so I'm going to go ahead and rewrite it. So I have x equals a negative 8y minus 15. But now I'm going to substitute in this value negative 2 for the y. So I have x equals a negative 8. I'm going to substitute in negative 2 for the y value minus 15. Negative 8 times a negative 2 is a positive 16 minus 15, x equals 1. We need to make sure that we write all of our solutions as an ordered pair. So in this case, it would be 1 comma negative 2. This would be my solution. Meaning I have two lines that intersect at the point 1, negative 2. Looking at the second example, I have negative 5x minus 7y equals 11. And I have x minus 2y equals a negative 9. Looking at this, I need to find the variable that does not have a coefficient. So looking, this variable right here, x, in my second equation does not have a number in front of it, a coefficient. So I'm going to solve for x. So to do that, I need to move over this 2y. So I do the opposite. It's negative, so I'm going to add 2y to both sides. So I get x equals 2y minus 9. Now I'm going to take this equation and I'm going to plug it in for the x value in the first equation. So what that looks like is I have a negative 5, but instead of x, I'm plugging in this 2y minus 9. I have minus 7y equals 11. So I'm going to distribute negative 5 times a 2y gives me a negative 10y. Negative 5 times a negative 9. Two negatives make a positive, and it's 45. Minus 7y equals 11. I combine my like terms. So in this one I have a negative 10y and a negative 7y. That gives me a negative 17y plus 45 equals 11. I need to move over the 45 by doing inverse operations. So 11 minus 45 gives me a negative 34. And on this side, I'm left with a negative 17y. The 45s cancel out. They make 0. To solve for y, I need to do the inverse operation. So I'm going to divide by a negative 17, divide by a negative 17. I get y equals 2 negatives make a positive. I should get a positive 2. Now that I know what y is, I need to plug it in to solve for x. So I have x equals 2. Instead of y, I'm going to plug in 2. Minus 9. 2 times 2 is 4 minus 9. And 4 minus 9 gives me a negative 5. So now I have solved for x, I have solved for y. I just need to write my solution as an ordered pair. So I have negative 5, comma 2. Again, what this means is these two lines intersect at the point negative 5, positive 2. Looking at my third and final example for the substitution method. Okay, I have negative 9x minus 3y equals a negative 2. And then I have y equals a negative 3x minus 4. Looking at this one, it is already solved for y, so I don't have to do that. It's already solved for the variable I want. So all I'm going to do is I'm going to take what y equals and plug it in. So I have a negative 9x minus 3, but instead of y, I'm plugging in a negative 3x minus 4. And it equals a negative 2. I need to distribute the negative 3 to the stuff in the parentheses. The negative 9x just hangs out. So negative 3 times a negative 3 gives me a positive 9x. A negative 3 times a negative 4 gives me a positive 12. Still equals negative 2. I go to combine my like terms. I have negative 9x plus 9x. Those end up making 0, so I'm left with 12 equals a negative 2. 12 equals a negative 2. But can 12 ever equal negative 2? No, it cannot. That is a false statement. 12 can never equal negative 2. So what this means is my two lines are going to end up being parallel. So there is no solution. If I were to put them in slope-intercept form, I would have the same slope. So this is the video for solving systems of equations by substitution.